Hi, I'm Martin Bailey from Global Graphics Software. Today I'm going to talk about variable data printing, what it is, how it works, and why Harlequin RIPs with Harlequin VariData in them can help you build a digital front end or DFE for a digital press that will drive your press at engine speed. Variable data printing is any job where all the pages are related. In other words, you're not simply printing a huge number of separate jobs, but where many of the pages taken as a whole are unique. That uniqueness may be in only a small way, perhaps only a single graphic or line of text that's different to every other instance of the same underlying design, while the majority of the artwork and content is the same. Or the uniqueness may be very significant, such as in photo books, or designs where the graphics are all variations from a small number of seed designs. The variation may be for process control, shipping and returns, security, customer or campaign driven, or for any other reason. Variable data has its roots in transactional and direct mail printing, but over the last couple of decades it's been expanding across many different sectors of print. Most variable marks are aimed either at the end user of the product, in other words the reader or consumer, or they're there to support production and supply chain logistics. So now it's used for transactional, direct mail and other promotional print, unique identifiers for tracking marketing campaigns such as on hoardings and posters, uniquely labelled or packaged products for gifting, unique products, e.g. phone cases or t-shirts customized with avatars and names. For production and supply chain, it can be serial numbers, batch codes, sheet or roll numbers, product identifiers, unique identifiers for track and trace on books, pharma, packaging for high-end goods, perhaps using GS1 codes. Interestingly, some of the logistics usage here would have historically been printed using coding and marking devices, but it's becoming part of the larger variable data print world because digital printing allows the print to be done closer to the manufacturing, filling or labeling line, both physically and in time. So some jobs are now being printed in one pass with both the graphics for the end user and the logistical data together. Simply because VDP is used across so many sectors, the terminology used has tended to diverge in each. So I'm going to define terms as I'm using them in this video. A variable data job is composed of a series of variants, and each variant is built for one recipient. The word recipient obviously comes from transactional and direct mail printing, for the person who will receive the printed item. But it's used with a broader meaning in the PDF VT standard, so we'll use it this way here as well. Outside of transaction and direct mail, a recipient will often not be a person. It may be whatever a label is going to be applied to, for instance. A variant may be a PDF page, part of a PDF page because you've imposed a number of items such as labels together, or a sequence of PDF pages. And I'm talking about PDF pages here because that's the terminology used in the PDF standard. It shouldn't be taken as meaning that VDP can only be used if you're printing actual pages. For the purpose of this video, I'm also going to tighten up the definition of variable data a bit further, to say that a variable data job is constructed from a combination of some graphics that are used in multiple variants and other graphics and or data that is only used for one. In other words, a job where every recipient gets something unique, but where processing can be optimized by caching and reuse. 25 years ago, we were using offset or flexo to generate pre-printed shells, and then digital printers, usually monochrome, to print simple graphics such as a name and address on top. Quite a lot of variable data printing is still rather similar in concept, especially for logistic information such as serial numbers. The big difference is that a lot of it is now produced using what the transactional world describes as a white paper workflow, where both static and variable graphics are printed in a single pass on a digital press. And, by the way, saying white paper workflow shouldn't be taken as limiting it to printing only on paper. As DFEs have become more powerful, as brands have acquired more and more data about their target audience, and as designers have learned more about what can be done to build compelling targeted visuals, variable data has expanded to do things that could not be achieved with pre-printed shells. This means more differences between the graphics used for each variant, and sometimes differences in layout as well. This is important because the real value of a digital press comes from printing jobs that could not be achieved with conventional press technology, or achieved profitably at least. Short-run printing is the gateway to digital printing for many users, but variable data is one obvious next step to maximizing profitability. So, what's the challenge for processing a variable data job in a DFE? In a word, or rather two, data rates. If I print 100,000 copies of a job, it'll be on press for several hours, or at least tens of minutes, and I have all of that time to do the preparation for the next job. If I print 240 copies digitally, it'll only take a few minutes or even seconds, and I'll have to have the next job ready to print it in that time. In other words, with a shorter run, I have less time to prepare each job than I would have had for a long run. I obviously don't want the press to be sitting idle waiting for the RIPs or the DFE. The impact on profitability of delays between jobs increases as run lengths get shorter, because every minute waiting is a larger proportion of the time for each job. But there are still multiple minutes or seconds to prepare the next job to print while the previous one is being printed. As an example, 240 copies takes 2 minutes for each job to print on a 120 page per minute press, so I have 2 minutes to prepare the next job. But if every page or label or carton or whatever is being printed has variable data on it, then at least some parts of every variant need to be processed through the DFE to do ripping, color management, half-tone screening, everything else required. And now I have even less time for each piece. I need to process every PDF page, every variant, fast enough to feed the digital press at full engine speed. For the very fastest presses, that may mean I have around 75 milliseconds for each A4 or US letter equivalent. Even at, say, 120 pages per minute, which is only 22 meters or 75 feet per minute for a typical narrow web label press, I only have half a second for each A4 or US letter equivalent. If I can't do that, if I can't keep that speed up, then I'm going to have to slow my press and take the hit on my profitability. Incidentally, this points up the fact that short-run and version jobs don't fall into VDP and can't be accelerated in the same way. If you've migrated from printing batches of 100,000 identical labels to runs of 240 identical labels, that's short run, it's not VDP. If you think about the data rates required, you'll see that you still don't need to process jobs through the RIP and DFE at full engine speed. You still have the time it takes to print 240 labels to prepare the next job to be sent to the inkjet heads. And versioning, perhaps for different languages, different retailers, etc., is simply a collection of short-run jobs. You might have 240 copies in English, 300 in French, 170 in German, etc. The goal of any variable data optimization is to reduce the time that it takes to prepare a job for printing, and that's exactly what Harlequin VariData does. In this diagram, each box is a single PDF page, and you can easily see what happens if it takes longer to prepare each page or each variable data variant than it takes to print it. The press has to wait for the next one. You can see those white gaps between the green printing blocks. On a sheet-fed press, you'll just see every sheet taking a little bit longer to be delivered. On a web-fed press, you'll need to widen the press speed down a bit or risk press starvation. In both cases, the profitability of the press is reduced because it's not achieving the desired throughput. In this second diagram, the prepare time is shorter than the print time, and the press can run at full rated speed. To misquote Charles Dickens, print time 20 milliseconds, prepare time 19.5 milliseconds, result happiness. Print time 20 milliseconds, prepare time 20.5 milliseconds, result misery. One of the easiest ways to understand how a DFE for a digital press can optimize processing of a variable data print job is to start by looking at how the job might have been created in the first place. A composition engine will typically be given a number of assets, which are the component graphics such as text, images, barcodes, etc., from which each variant will be constructed. Some of those assets might be used on every variant, some on a subset of variants, and some only once. In many cases, there will be metadata about the recipients. For direct mail, it might be their shopping history, etc. For serial number on label, it may be number ranges and the formats to be used. And then there's a set of rules required to tell the composition engine how to combine the assets into variants, in many cases using the metadata. The complexity of rules can vary hugely. At the simplest end might be a rule to place a serial number in a specific font, specific size and specific color at a specified location on each label, with instructions to increment the number by 1 for each variant. And I'm ignoring complexities around incrementing numbers when slitting a roll into ribbons, etc., because frankly it doesn't matter for the purposes of this discussion. At the other end of the scale, the composition engine may be dynamically generating graphics such as pie charts and combining those with assets selected on the basis of the recipient metadata. All of this is most easily understood by working through an example. So I'm going to use this direct mail postcard. I've chosen it because it demonstrates a middling level of VDP complexity and therefore it's more or less applicable to everything. It's a bit more complex than most labels, packaging and industrial print are now, and a bit less than the most complex direct mail. And yes, this pretty obviously has never been anywhere near a marketing team or designer, but still illustrates the principles okay. The job starts with a static background. The campaign is intended to persuade people who bought a car a couple of years ago to trade it in for a new one, so it includes details on the dealership they might go to. We have text and a map for each of the 3 dealers in the campaign. Which of these assets will be used depends on the recipient metadata. So let's pick one of those dealerships. In this campaign, the Executive Autos dealership has 4 sales executives and we'll be adding data for one of those. Moving on to the recipients themselves, we know what colour car they bought last time, so we'll put up an image of a car in the same colour again. We obviously also know the recipient's name and can create a personalized URL, a PURL, for them and build a QR code to carry that. And that, within the limitations of my PowerPoint technique, is the whole postcard for one recipient. In a variable data print file, some graphics are used many times at the same size and rotation, like the lion logo and the car images in this example. Ideally, the RIP should process each one of those once, converting it into the correct color space and resolution for the output device, handling any image rotation, etc. And then those partial page rasters can be put back together again in a complete output on the way to the print heads. And that's exactly what Harlequin VariData does. It scans the file looking for graphics and combinations of graphics that are used together multiple times, then tweaks the structures from the PDF a bit to maximize its ability to combine graphics where it makes sense while ensuring that the visual appearance is not changed. So in this example, the blue car image is used once, the red one twice, the green one twice, and the yellow one once. And then the lion logo is used on every one of those variants. Each of those graphics or collections of graphics is rendered to a separate partial page raster, and then Harlequin delivers metadata describing what collection of those rasters are required to recomposite each piece of output. In a sense, it's doing what the composition engine did to create the PDF in the first place in reverse, and then delivering all of the assets or combinations of assets in a form that's ready to print. Each of the partial page rasters includes a mask to ensure that they can be overlaid during recomposition and retain all knockouts and overprints, supporting constructs like white variable text over a coloured background. Okay, enough PowerPoint. The best way to understand all of that is by seeing the results. So I'm going to process this sample PDF file, which has postcards for 201 recipients through Harlequin VariData, and show you what comes out at the end. So if I walk through, here's page 1, page 2, page 3, page 4, page 5. Now I'm going to step back to the first variant. We'll be looking at the components that Harlequin breaks it into later. So remember that it's to Ashley from Eva, and the car is silver. Okay, let's close that down. I'm using a program called Faststone Image Viewer to look at TIFF files that are created by the RIP. There are several tools that I could have chosen, but this one is reasonably fast and doesn't have too many limitations on different file support. A lot of DFEs running variable data jobs for production won't make TIFF files, or indeed any files, on disk. They'll stream the rasters in memory direct from Harlequin to the printing heads, but saving to TIFF means that I have something that I can show easily. I'm going to kick off Harlequin processing the file. Now, even though I said Faststone is quite fast, it takes longer for it to build previews for the files that I'm generating than it does to generate them in the first place. So while we're waiting a few seconds for those, I wanted to show you this diagnostic data that Harlequin reported. This is the raw form of the Harlequin core that our OEM partners build their DFE and digital breast solutions around. Pretty much all systems that those OEMs sell have user-friendly user interfaces built around them rather than showing anything like this. This diagnostic data is available to our OEM partners as they build DFEs for digital presses, but won't usually be visible in the products that they create, at least in this form. You can see from this report that Harlequin retained 2 rasters from page 1, which will be used a total of 56 times, and then retained 2 rasters from page 2, which will be used a total of 62 times, etc. Clearly, Harlequin VariData has found graphics and combinations of graphics that are worth splitting out and caching. We should have all of the TIFF files showing nicely now, so let's switch back to Faststone. I'm going to start by sorting the output files by size because it helps to see what the RIP has done. This is a relatively simple design with no heavyweight graphics on the static background, so you can see it's combined all of the data for each sales executive with the dealer info and the static background into a single raster for each. In this campaign there were 3 dealers with 4 sales executives each, so that means there are 12 rasters amongst the largest files, 1 per executive. The rest of the biggest files are the 5 car images in different colours. And then there are 201 very small rasters, 1 for each recipient, showing their name and the QR code with their pearl. If I now sort the rasters by time and date, you can see how the delivery sequence works. First out, if I enlarge that, is the raster for the static background and dealer and sales info as the first postcard. You'll remember that the first card is from Eva. Then there's the silver car, and then the recipient info for the first card, and it's to Ashley. Those first 3 rasters provide everything required to print the first variant. Then we have the same sequence for the second card, and again for the third. By the time we get to the 4th and the 5th variants, we've already processed a background for this executive, so we don't need another background. We just need the car and the recipient detail. For the next few variants, we've already processed a card for the car image required, so we only need a background and recipient info. And from that point on, most of the rasters are just the recipient info, with a few latecomers of sales executives, presumably rushing around to catch up to their monthly targets. And pretty soon we're into a state where all we need for each postcard is the very small area that's specific to each recipient. I've been talking so far as if there's a single version of Harlequin VariData. In fact, there are two, giving different levels of acceleration and requiring different amounts of integration effort. With Harlequin VariData in internal mode, all of the work is done inside the RIP. The output produced is the same as it would have been without VariData. The difference is it's faster, but does benefit from a little bit more memory. In external mode, the RIP does all of the job analysis, determines how pages should be split up to optimize reused objects, and then delivers a collection of partial page rasters as you've just seen. It also delivers metadata that forms a recipe to show which partial page rasters need to be put together in what order and what positions to build each final variant. Pushing the recomposition out to OEM code means that each can make maximum use of their own technologies. Some choose to do work on custom hardware, perhaps on the interface boards for driving their print heads, others on GPUs, others in software, etc. What I've just been demonstrating was external mode because there's virtually nothing to see in internal mode. The amount that Harlequin VariData can accelerate different jobs depends on many factors, including the size and complexity of individual assets such as images within the job, the efficiency with which the job has been constructed, the hardware on which Harlequin is running, especially around the amount and speed of memory and CPU cache sizes, and how much additional processing is being done on the raster data delivered by Harlequin on the same server as the RIP. But to give a rough idea, I processed the 201 pages of the car postcard sample on my laptop with some pretty basic configurations and compared the times. As you can see in the table, Harlequin VariData in internal mode increased the throughput by 36%, and typically that would be higher in jobs with more complex graphics in the static background, lower if the background were even simpler. And in external mode, Harlequin VariData increased the throughput by a factor of over 2.5 times. Of course, the real question is whether it achieves the desired result in the field, printing jobs for real customers. On the left here is a quote from HP Indigo, who use Harlequin Core in the DFEs for all of their presses, extolling the value of variable data printing in helping print service providers and converters build volume and margins. And they should know, they've been using Harlequin VariData for over a decade and have worked with us to ensure that it's been continuously improved over that time through development responding to customers' needs and market trends. And on the right is a quote from the HP PageWide Industrial Group. They build and sell inkjet presses with the highest throughput that I know of, achieving over 50,000 square meters per hour, so every last millisecond counts in processing jobs. They're using Harlequin VariData as well as part of their solution to deliver many tens of gigabytes of raster data per second to the inkjet heads. There's more information on Global Graphics Software's technology components for building DFEs such as Harlequin Core and Harlequin VariData on our website at globalgraphics.com, and that includes a white paper on Harlequin VariData. If you have any questions or want to discuss our technologies further, please don't hesitate to drop me a line at info@globalgraphics.com. And there are more videos on the Global Graphics TV channel on YouTube, including one digging deeper into data rate and one on other ways in which Harlequin Core can help you scale your DFE to meet the demands of your current or next digital press. If your interest is more on the composition end, the creation of variable data PDF files, you'll probably find our guide called Full Speed Ahead, How to Make Variable Data PDF Files That Won't Slow Your Digital Press, useful. It can be downloaded from globalgraphics.com/fullspeedahead. Thanks for listening, and I hope you found this interesting and useful.